Hello guys, welcome on Tesla Adventures. In this video we are going to discuss a very important and very tough problem of magnetism. You can see that this is circular magnetic field lines which are in YZ plane. Okay, so it is very important to note that these field lines are in YZ planes and these are concentric circles because magnetic field is radial, so it is B is equal to B naught R, and this region is extending till a distance of delta x in the forward direction where delta x is small. The ion beams are moving with some velocity v, like that. This is the extension of this magnetic field region, and the ion beam is moving with some velocity which is represented by this red lines, like that you can see. And this due to the radial nature of magnetic field, you can see that magnetic force would be acting in the downward direction, because if field lines are coming at this point, you can imagine that the field lines are coming out of the plane, so magnetic field force would be acting in the downward direction. Okay, and similarly this force will be variable because each of the particle is incident on this field lines at a distance which is variable from the axis, therefore magnetic field is variable. So what we have to find, that what is the focus of this magnetic lens. You can see that these charged particles will be focused at some point, so we have to find out this focus. So I hope you understood the question completely, and now let us solve it. So we know that the time taken by the beam of charged particles to travel this distance delta x will be t will be equal to delta x by v, because we can say that the force is acting in the negative y direction, so the component of velocity along x axis will remain same as v. Therefore the time taken by the particles to travel this distance will be delta x by v. Now the force F acting on any particle which is at a distance of r is F is equal to q v into b is b naught r, and this is the force. So force, the change in momentum dp will be equal to F dt, where dt is the small time. This is obviously small time because delta x is given as a small. So the change in momentum in y direction is F dt. So F is q v b naught r into dt is delta x by v. Okay, so cancelling this v with v, so delta p will be equal to q b naught r delta x. Okay, and if we find out, if we can easily imagine that this will be the momentum in y direction delta p, and x direction momentum will remain same. So if we need to find out this angle theta, we can say that theta, which is a small angle because delta x is small, will be equal to delta p upon original momentum p. So theta will be equal to q b naught r into delta x by original momentum is mv. This is theta, and obviously you can see that this angle is theta, therefore this angle will be also theta, and tan theta from this triangle will be r by f. So theta will be equal to r by f. So cancelling r with r, this f will be equal to mv by q b naught delta x. This will be the focal length of this magnetic lens, and all these particles will be focused at this position. See, if this delta x was not small, then we would have to do the integrations, so that would be a different process. So, but in this problem we do not have to do the integration because delta x is small. So this is the final result. Thank you.